Hello, my name is Ian Watson, and I'm the Executive Director of the American Membrane Technology Association, fondly referred to as AMTA. This is a continuation of our chats with the pioneers, in which we are trying to record for posterity, or maybe longer, the efforts of the early pioneers in the development of membrane technology. AMTA is a technical association that advocates the use of membrane technology for water treatment, ranging from wastewater reclamation and reuse to seawater desalination. The heart of the technology is the membrane. About 2.5 years ago, the board of directors of AMTA decided that we should make an effort to interview as many of the early pioneers in the development of this technology, not only the membrane, but also the membrane systems that came along with it, as a way of preserving the history of this technology. The roots of this technology are in the United States, and specifically in Southern California. And many of the people who worked in the early days live in and around the San Diego area. AMTA's intent is to post segments of these interviews or chats on our website so that the upcoming generation of engineers and scientists understand what went into the development of this technology and its use throughout the world today. This is Terry Smith on my left, Rick Leeson, Ron Fox, and Tom Wolf. Thank you for coming. This is another in AMTA's series of chats with the pioneers. We consider you all pioneers. And I'd like to start off by asking you to tell us a little bit about your background in the industry, where you started. And Tom, why don't you go ahead?
Oh, well, that'd be appropriate. I actually started in fluid systems, which was Roga Division then in 1966, right out of high school. And it was one of these jobs that was a summer student job. And I was very fortunate to have gone to high school with the son of the executive vice president of GA, who organized my summer job. And I was interviewed by Isidore Nussbaum, who really had to hire me. So he wanted to see if I knew how to pipette, and he made me suck up some solution, and he said, okay, you're hired. And I came to work and ended up working for Al Hatcher. I don't know, anyone remember Al Hatcher? Al Hatcher was the original membrane maker at Fluid Systems. And the interesting thing about him, he was mixing up all these membranes in solvents, and he was a chain smoker. I'm talking chain smoker, start the next one from the other one. And so it was really a fun experience, and I was very fortunate because my university, UC San Diego, is right across the street from the original General Atomic. And so I ended up keeping that job all through and until 1973, when I left General Atomic to go, which was then Fluid Systems, to work for the European distributor called Rheinstahl Thyssen at that time, and worked there for not that long, 6-7 months. And then from that point, I went off from the reverse osmosis industry into sailing and pesticides, and it was a number of years before I got back to the water treatment industry with the RCC. And so that's kind of the early years.
Okay, Ron?
Oh, well, the one thing I would say about Al Hatcher is the fact that I was watching him mixing one day with a chain smoking
with cigarette. The ash falling in?
Yeah, the ash went into the casting solution. Well, it's a good thing he didn't blow the place up. It's just full of acetone, but somehow the mixture wasn't quite right for that. Didn't bother him, though. In this day and age, you can't even smoke within 100 feet of the building, let alone inside. Well, okay, I graduated from Berkeley in chemistry and I went to work for Convair Scientific Research Lab. And while working there, I met a guy after about a year, Bob Riley. And he was a very fine organic chemist, could run about 3 or 4 reactions simultaneously. So we spent a lot of time together. Anyway, I left there and went to General Atomic and went into the field of electrochemistry. And a couple of years later, Merton and Lonsdale were looking for an organic chemist because they were starting up the first government-supported research in reverse osmosis membranes, cellulosic membranes. And I suggested Bob Riley. I said, hey, there's a guy that he's really good. So I told Merton, I said, you'll enjoy meeting him. So they did. And Riley's been in the business ever since. Anyway, so he came to work in '62, and I was in electrochemistry working with other people. But next door to me was all this membrane research going on. So I used to sit there and eat lunch with the guys. And after about 10 years, actually only 5 years, the book was written by Merton, Desalination by Reverse Osmosis.
There it is.
And there's the book. Well, the green copy, yes. And at about the same time, they established a production facility down in Harbor Drive, which is separate from General Atomic by about, 12, 13 miles, something. And so they started that operation. And meantime, about 5 years later, I was interested in this thing, very interested, eating lunch with these guys and seeing this happening, and it suddenly now is becoming a commercial entity. I said to Riley one day, I said, well, what are they doing down at Harbor Drive? Because Riley didn't have extra money in his contract. He says, hey, they've got a lot of contract writing going on down at Harbor Drive. Why don't you go see those guys? And I said, who? And he says, well, why don't you start with Jim Kruver? So I went down and talked with Jim Kruver, who was a very diplomatic and fine guy. And he said, the best thing you can do is talk with Seymour Kremen because he's got 3 proposals he's working on. So I went to see Seymour, and he says, I need to have a resume in my hands. Yeah, I don't care if it's written on the back of an envelope. I need to have it now. And then he says, also, I want to see a copy of one of your recent reports. So he put you to the test, and I came up with those things. He read that and decided I could write, so I contributed to the proposals that he was writing. And, of course, we write ourselves in, and so I started off in research and development at General Atomic, Roga Division in Harbor Drive in about 72, 73, and stayed there working on membranes for about 3 years, and I finally joined Bob Riley in his. He had a big contract that had come in, and we had expired our contract, so worked with him, and that was the genesis of the thin film composite membrane, and I was very anxious to do that. I spent about 1.5 years there and then went to another company called Membrane Systems for different reasons, mostly we'll just say financially oriented reasons, and in many different ways. Then Dick Sudak ran that operation, and he was a very good guy, good boss, very, very fair, and wanted the truth at all times, and I appreciated working with him. Not very patient, but hey, he was just, that's the way people are. He was a good man. So he quit after 3 years there, and they appointed me as director of the outfit, and I was, we had 17 people, something like that. So I was director of membrane research for Hydronautics. Hydronautics was a parent company of Membrane Systems. And so developed all the cellulosic membranes there, and came up to, on many occasions, to Goleta, where the Hydronautics facility was, and worked with Rick Leeson and his people there in getting membranes working, and then we started the thin film composite manufacturing, but it kind of stayed in San Diego for a long time. After some time, I'm probably skipping a point here, but Hydronautics was sold to Roman Haas. And I thought Roman Haas was a very good company. It seemed in every way to be. and very, very brilliant people, technical staff and whatnot. They're good to work with. And a couple of years or so later after that, they put the company up for sale. I didn't like that too well, because who knows who buys it, you know, investors and people like that really don't know what membranes are. We've all dealt with those types of people, and sometimes it's way too much to bring them up to speed, particularly if people are feeding the financial kitty. They don't understand about time constraints and technical matters at all. So anyway, I joined Desalination Systems. I used to have lunch every about a year and a half with Don Bray, and so one day I told him about it. I said, it's going to be sold. Who knows who's going to buy it? Anybody will buy it. Some investors and stuff. He says, why don't you come and let's make some membranes together? Those were his words. I said, well, why don't we? So I left there and went there for the next 11 years. Worked making membranes, was director of research and development at Desalination Systems. After a certain period of time, they were sold to Osmonics, then Osmonics to GE. I left there and began another company called Sepro, which was very, very understaffed. And the little staff that was there didn't really do anything. I don't want to say that badly. It's true. They were, they're salespeople. They're people that can't dig the ditches and install the electrical and get the machines working and get them machined and all that. They just aren't able. So I was doing everything myself, and finally I decided. And then they hired Bill Light, and he was another person to work with. But after about 5 months, I decided to be a consultant. So I had a contract with them, so I worked out a deal with the investors there and said, look, I'll give you whatever time you need. You don't want to spend the money, and I don't want to spend the time. How's that going to work out? So I did a little consulting with them for some months thereafter, but ended up being a membrane consultant for the next 10 years, and still am. I got myself into more than I realized, but that's the way it goes. And anyway, that's where I am today.
Now, you mentioned Bill Light. He was also at Fluid Systems, wasn't he?
He was for a while.
For a while.
Yeah, later on.
Yeah. Rick, what about you?
Well, I, like Ron, started at UC Berkeley a couple of years after Ron, but when I graduated, and it was in chemical engineering, I had no idea what I wanted to do, but I happened to get an interview with General Atomic, and I thought, San Diego, I knew nothing about membrane. I couldn't even imagine really what the future was going to be, but it just seems like a great place to come to San Diego, and so I came down and worked with Harry Lonsdale. It was my first job in the lab area, and after about a year, I decided I was really more interested in hands-on things. So talking about names and people, went down to Harbor Drive under Dick Studak and was involved in government contracts for larger scale elements. The commercial practice at that time was just small 4-inch elements, which were, by today's standards, pretty
Rudimentary.
Yeah, you got to start somewhere. And so I was involved in a government-funded contract to develop the first 8-inch, and then from there, working with Dick, we did a 12 3/4-inch element that went on to be used in Yuma, and so I kind of became real hands-on with the product development part and decided I really liked that part of the business more than the lab. And I went on to hydronautics, like some of my colleagues here, and started that operation in manufacturing. And kind of look back and am amazed how successful hydronautics has been. 'Cause, Ron and I were kind of employee number 1 or 2 in those early days. And so I've basically stayed in membrane all my life. When I was involved in Roman Haas, I was doing sales and marketing and traveled the world promoting the product, which was a great opportunity for me to learn and see parts of the world. And from there, I ended up at Osmonics, another name that Ron mentioned, and I remember being reunited with Ron when Osmonics purchased DeSal. So it's a small world, you know.
Yeah.
As I'm sure this program is probably showing how people's lives cross back and forth. But I guess the interesting thing was that having started from not really having any insight into membrane, I've now worked for 43, 44 years and done nothing but membrane and all different forms of things, and I haven't gotten rich, but it's been enjoyable. And I'm amazed how successful.
You're not alone in that regard.
Yeah, well, I guess.
Well, one thing that I never understood, perhaps you could clarify it for posterity, Rick,
Sure.
is why you would suddenly move from San Diego to Minnesota.
I wanted to find out about the seasons, and I did, and I moved back to San Diego. So you have to find that out.
It was a quick study.
The voyage of
well,
discovery.
it took me 6 years to learn, but it's actually, I've got to say, there is San Diego, and there is Minnesota, and there's Boston. There's really 3 membrane cities
That's right.
in the world, and so,
That's right.
at least in the U.S. So I've been in 2 of the 3. I've never aspired to Boston.
Terry, what about you?
Well, I was a naval officer during the Vietnam era and decided it was time to do something else. So in the fall of '73, I'm looking around and my wife actually met Jerry Foreman's wife, and they were quite close. He lived about a block away from me, and she found out what Jerry did, something about reverse osmosis. And so I said, And I said, well, are they hiring? And found out, turns out they did have some openings. So I went to the library, and the book cover was red, and I don't remember what it was, but it was a, Cliff Notes to reverse osmosis, I think. And so I spent Sunday afternoon reading it, and Jerry set up an interview with 5 people, and I can only remember about 3 or 4 of the names: Charlie Hull, Nussbaum, and him, of course, that's 3, and 2 others. And I had written down what I thought were perceptive questions and asked them, and I don't know, they must have thought I knew something. But in any case, I think it also helped that the general manager was also a Naval Academy grad, because that probably sealed the deal. So they hired me in their first employee in their marketing training program. And so for the first 3 or 4 months, I was actually in R&D doing some things, and kind of blocked that out. And then moved on to field service. Well, then I was in there for about a year or so, and ended up managing that group, and from there went into engineering and never got into marketing. So I'm not sure they really got their money's worth in that area. But I worked for Jack Luce for a while, and he's an early pioneer in this group as well. And from there, Jack had left and formed a company working for the Saudis called El Khother. And so I went to work as his engineering manager, and we did that for 5 years until the Saudis thought they could do it better and cheaper. So they turned us all loose, and I ended up at Filmtech. And then Dow Chemical bought us in '85, and I got promoted to Midland, Michigan. Well, I had lived and was born in Minneapolis, so I kind of knew about cold weather. And so I stuck that out for 3 years and then finagled away back to California. So I ended up working for the Filmtech Dow connection for about 17 years. And then it was time to move on, because retirement at Dow the average was about 56, and I was slightly past that at the time, I guess. And so I decided I better find another job. So I ended up working for the Japanese in a company called Toray Membrane America, which later morphed into Toray Membrane USA. And so I've been with the Japanese now for 11 years, and ended up now as a vice president of marketing and sales. But
Now, were you all at Fluid Systems at the same time? Did
Pretty
you all know
much.
each other then?
Overlap,
Yeah,
Terry and I did not overlap, but we the rest of us
Yep.
overlapped.
yeah, the other 3 of us were there at the same time.
Okay. Okay. Good.
And, so
Yeah, I noticed from your resume, Tom, that you described your time in Europe as sailing and some.
Of course.
And I
Well,
thought,
I'll tell you how this happened is I went on a trip with fluid systems distributor, and they were trying to sell something to Swissair, and the Swissair guys were there at this breakfast, and the Swissair guys realized that they needed help, and the Swissair guy said, well, you should come and work in Germany. And I said, well, will they hire me? And he said, sure. And so that evening, the Swissair guys who were the client talked to the German company, and because he came down and offered me a job the next morning at breakfast. Said, you will come to Germany? I said, sure. And so 30 days later, I was on the plane to Germany and worked there for 6 months or so, and then got a better offer running a big sailboat in the Caribbean, and moved to the Caribbean, went sailing, worked for a pesticide company for a while, went sailing again, met my wife, came back. She didn't want to live in Arizona, and that's when I went to work for RCC, which is Boeing at that time.
Yeah, that's when you moved to Grass Valley?
No, that was much later. This was earlier. I moved into Seattle.
Seattle.
Yeah. And that was organized by Jack Laughlin mainly that set that up for me. And we worked there until '86 with RCC. And I really liked Boeing treats you very well. In '86 we said, time to go. And they were very nice, gave me a year's pay, layoff, and RCC was going down, but everyone had a job at Boeing if you wanted to go back to work at Boeing, or you could get laid off, and I had enough seniority to get a year, and so that's what moved me to Grass Valley, and from there we started, mostly in the software business, but I worked with Carl Hickman, who was here, and we did control systems and a lot of the design software. And then 4 or 5 years ago, Randy Truby talked me into coming to Torrey. And Terry and I have been there. He's way ahead of me, but since I've been there 4 years now, a little over 4.
Now, wasn't RCC ultimately sold to Ionics?
RCC was first sold to, RCC was partially owned by Reading and Bates in El Paso Natural Gas, and El Paso Natural Gas got out of it, and then Boeing had 2/3, and then Reading and Bates wanted more of it, so Reading and Bates took it over for a while, partially 60% of it, and then Halliburton bought it, and then Halliburton sold it to Ionics.
Okay.
And that's how it got to Ionics. And I was the director of R&D for RCC, but we did big reverse osmosis systems. We had the San Juan system, which was 1,500 gallons a minute, which was one of the bigger ones around. And of course, our big product were the evaporators.
Right.
But we developed the seeded slurry RO process, which never went anywhere, but we did a lot of work on that in the mines in South Africa. And so you learn the whole other side, the thermal evaporation side of the business, which is a completely different orientation from the membranes, But
Yeah.
so I've seen both sides of it, and right now, I work for Torrey, but I'm also board of advisors for a water asset fund.
Would you pass this down to Tom and ask him if he'd like to explain it?
This picture. You've seen this already. Someone's taken a picture of this, right?
Richard, where did you get that?
I sent it to him.
Oh, you said it.
Yeah, okay. So this was at Fluid Systems, 1971, and Gulf was then owned, the proud owner of Fluid Systems. Gulf General Atomic, I think we called it right then. And they wanted to do this promotional deal, and so they sent down Andy, and they said get out in the lab and show him some membranes, and we're going to take some pictures, and there it is.
Yeah.
Time magazine.
They were doing
So it was
video thing for they're sponsoring the national conventions, political convention things, and you remember the tank with the black water that was supposed to be purified?
Yes.
Yeah, so that was all they spent.
What was this, Rick?
Well, this was an oil company,
Yeah.
and
So they wanted to project a clean technology image, so they had this involvement. So they bought, I think it was actually considered a sale for the Rogas. They bought an RO system to use solely in the commercial, and its purpose was to turn dark water into pure, pristine water for a 30-second commercial. And I guess
And
that
of course,
would
it
have
was
been.
it was food coloring, but you know,
Yeah.
Yeah, in fact, there was a R&D effort to find out what dye the membrane could tolerate and
Yeah.
so it would look credible on the food. So, it was, and then
anyway,
and
that's the picture. Yes,
But it's kind of like,
Yeah, no,
remember DuPont's miniature unit they used to carry around with the 3 tanks?
this was a similar
large-scale
type of
version
thing.
of
In
that.
fact, I don't know who came up with the idea first, but
I remember we had a AMTA's predecessor, Noisia, had a conference in Sarasota, and I think it was about 1978. And Fluid Systems brought down a unit and parked it beside the hotel, tossed a hose into Sarasota Bay. You remember that?
well, I remember that was at a time when people couldn't visualize what RO is.
Right.
Now pretty much everyone knows because they can relate to it through Aquafina or something like that. It
Yeah,
touches people or they have an under the sink unit.
Right.
25, 30 years ago when we were talking about it, no one knew what
No
it
one knew
was.
what
It
it
was
was.
membrane and, they assumed it was biological, some animal skins that were being used to. So, I think that was a lot of that type of thing is having demonstrations where people could see, in a tangible way
Right. Right.
what could be done.
Well, even the applications weren't developed, and so we were continually doing pilot studies with some really nasty stuff that most of them never went anywhere, but some of them were successful and went on to applications that were commercialized later.
Yeah. Yeah, I remember when I first went down to Fort Myers in Sanibel, because we had the old ED plant down there, and I had done a couple of studies for OSW, one of which involved the state of Montana. It's one of the first state studies that was done. And part of our scope was to investigate this relatively new technology called reverse osmosis. And so we did that, and I thought, this is not bad. So we got to Sanibel, and they had made a pretty significant investment in this ED plant. And I essentially said, let's build something else. So we did. And ED plant's long gone.
You're one of Hydronautics' first customers, too.
That's right.
For
That's right.
Sanibel Island,
That's
I remember
right.
that. It's-
You know, but it's interesting to see that these days, the now, there was ED and then RO, and really RO, the basic membrane element has been unchanged since we worked on the original one. And it's just in the last probably 5
They've
or
gotten
6.
bigger.
They've gotten bigger.
Yeah,
and they work
longer.
and they work better, for sure. But basically they're the same thing. And it's just in the last 4 or 5 years that people have started coming out with new membranes, the carbon nanotubes, the graphene ones, the porphyrin ones, and that we're starting to see a new change. And you can kind of watch it because these guys are all young and they haven't been told that it can't be done, and they're out doing it. It's pretty fascinating to see this.
Do you think they'll be able to violate the laws of thermodynamics?
We won't violate the laws of thermodynamics. And actually, I did a study on that not too long ago because we wanted to put in the Tori software a comparison of the plant performance compared to the theoretical minimum energy you could obtain in a system. And so I launched a few studies on where we are as opposed, compared to theoretical minimum energy based on osmotic pressure at completely reversible conditions. And, the biggest plants are only they're only 2 to 3 times the theoretical minimum energy. So I think that's a pretty fantastic achievement to get that close,
How much closer do you think we can get?
No, we can probably get down 2 times,
2
a little
times?
less, yeah.
Yeah, because you still, does the theoretical energy include hydraulic losses in the system and all that kind
No,
of thing?
the theoretical energy is just what it takes to force water
Through the
against the osmotic pressure,
Right.
against
Right.
to pressurize that. But the energy recovery devices have made a huge difference. And look at these pumps now. I mean, we thought 65% was great efficiency, right? And you can buy off the shelf a 90% efficiency pump with a built-in energy recovery device.
Yep.
I mean, this industry's come a long way
Yeah. Yeah.
in that.
The speaking about nanomembranes or nanotechnology modified membranes,
Okay.
what do you think is the future of those types of devices compared to what we would refer to as a conventional RO membrane?
Well, I mean, the one nano H2O, of course, is almost a conventional membrane with modified parts dispersed through it. The carbon nanotube ones, a lot of promise. You know, the only ones that seem to actually be working right now are the ones where they built the carbon nanotubes in situ so they're not blocked. Those are very, very expensive to do, and there is an intrinsic, even though you can measure the passage through the tube, there's a hydraulic loss going through these little tubes. You know, they're tiny, they're 1 nanometer or less in diameter, and that's a few molecules of water going through. And so the question is, how can you support these things in a way to get them thin enough so that, so I think we're coming to where we have a physical
Limitation, yeah.
physical limitation of how to support these things. And then, of course, the ultimate of this is the graphene nanotube, which I don't know if you've seen this. This is the latest from MIT. You have a piece of graphene, which is a layer of graphite, one molecule of graphite thick, so one ring. And you punch holes in this with an electron beam. Once again, at that 1 nanometer, 10 angstroms, 1 nanometer, or slightly less is kind of the optimum size water fits through, ions won't. And now you have a very, very short passage, but the question is, how do you support this? And if you could figure out a way to cast this graphene, for example, on the top of a polysulfone support that'll give it some flexibility, I think that you would see a big improvement there, because that you're going to lose a lot of losses. And if you can keep them uniform, then you're not going to get much back diffusion of the salts like we have in the conventional membranes.
Right.
One of the things that you have to keep, anything that's dealing with water on a big scale, you got to keep it clean.
Yeah.
And there's a lot of things that sort of work in laboratory environments
Oh,
that
yeah.
are fundamentally sound. I mean, I remember being kind of excited by diffusion systems, per evaporation system. Remember,
Yep, right.
Gore had membrane, and they came out with it, and they had a lot of research, and they were intelligent people. They completely abandoned it because basically they could never keep the surface
Yeah,
clean
but it's
enough.
back.
Right, but it's back.
MEMSIS
It's
is
back, but
Well, but after 20 years,
20
I think
plus
that-
years.
It's
that
back.
it's still got those fundamental problems. You have to keep things clean,
Well,
and
per evaporation is the thermal process. Still,
but
you
I
gotta
mean,
do-
you have the same common goal of theoretical energy separation.
you
So
yeah.
But talking about membranes now, we've seen, and I can recall, not in any way involved in membrane research development, but I can remember reading articles about membranes that were like better than sliced bread in the lab.
Yeah.
And then you get them out into the field and you actually make them into a commercial product. They last about 200 hours.
Yeah,
And this is, and it's the same with the thermal. I'm sure you remember the stories about, massive increases in heat transfer coefficients and all this other stuff, and you never saw them again.
No, I just saw one the other day. Rotational energy. Make a vortex and you have some, anyway.
Yeah.
No, you can't. Physics is physics. You're not going to beat that. But these membranes are getting better. There's new membranes. And paradoxically, Rick, if you talk to like Yoram Cohen and a few of the other people, rough membrane surfaces may offer some real advantages in anti-fouling surfaces. And
Well, I mean, I think people were talking about that with a lot of the work that was done in Orange County a long time ago, and surface roughness. People, even Hydronautics, tried to patent sort of rough membranes as part of one of their
But
technologies.
wasn't that always one of the benefits of cellulose acetate? The surface was so smooth compared to TFC that it was inherently less fouling prone.
I think people made claims. Basically, it's a product, and you're going to
Different charge too.
sell whatever works. But you look, and there's still some cellulose acetate left, but not too much of it. And yet it worked. It got the foot in the door, really, when you think about it.
For those that are running it, they're doing business like gangbusters. They just don't talk about it a lot.
Well, personally, the membrane I'd like to see is the forward osmosis membrane. Think about this. Every coastal sewage treatment plant could have a power recovery system sitting there on the sewage. It's going to mix with the ocean water anyway. You don't have to worry about, NSF type approval. It says no one's going to drink the water. You're just going to put the electricity into the system, and they can be small, big, however. And this is, this is pretty interesting stuff that these forward osmosis could do. If you could actually get a membrane that worked.
Does it, yes.
Yeah. And of course, that's, the carbon nanotubes. We thought, well, okay, you can have the carbon nanotubes, and so we'll have such length, and you can have them supported, and you're going to have water on both sides of the tubes, and it's just transported through the tubes. No one has that yet, but
It's the support, that's the problem.
that's exactly what it is, yeah.
Now, Terry, you've been more on the marketing side of things.
I had
For
a
the
frontal
last
lobotomy when I left engineering and went into sales.
I thought you had a revelation.
Epiphany.
An epiphany, yeah.
Lobotomy could be an epiphany.
Yeah, I guess. Yeah.
But there's always been,
It's done.
always been a lot of, well, there hasn't always been, because at one time, it was DuPont and Fluid Systems, and that was Oroga, that was about it.
Correct.
But in more recent times, there's been not a host of competing membranes, but certainly there's at least half a dozen around.
There's half a dozen, but it comes down to three basic ones.
Right. Right.
Dow Chemical is by far the largest, and followed by Hydronics, and Tory's third.
But there are rumors of something coming out of China soon. That
Well, I understand that there's been some casting machines sold with plans taken from U.S. equipment manufacturers and are being built in China.
Yeah, I think there's been a couple of generations. There
Yeah.
were first generation ones operating 5-10 years ago, and they're making product.
the same thing happened to Seihan. They were making membranes from flat sheet that they purchased here,
Yeah.
and it wasn't long before they had their own materials.
Well, Tory's making membranes in China. Toray Blue Star membrane, we have that, and I understand Dow has just started announced plans for a membrane factory too, right, Terry?
Yeah, that's correct, and I think they're also going to make some in Saudi Arabia.
But are they going to make them for sale there, or are they going to,
Primarily, I think.
or are they going to bring them back here?
Well, I think there's still a resistance to buying membrane made in China in the U.S. I'm not entirely sure about that, but I
But it
think
would
it's
have to get NSF approval for one thing.
Well, yeah, that only takes money. But what's happening, though, is the price of elements, because of the Asia influence, is dropped.
Right.
And I think you can go fully automated and reduce your labor component to the minimum, but still going forward, it's tough to make a buck. It really is. And, so there may be some fallout.
Now, is that gonna show up in less R&D investment?
I would think so, unless you have really deep pockets. Dow Chemical certainly has the deepest pockets, and they can do
Yeah,
pretty
but
much what they want.
even so, that
But-
ultimately they expect a return on their investment.
Yeah, and in my case, working for Tory, well, we're sort of a footnote on their stockholders report, and their big business is carbon fiber.
Mhm.
And they're 67% of the Dreamliner is carbon fiber, and it's all Tory. So they have a couple plants in the U.S., so that's a big business for them. And so I think the next few years are going to be tough on some of the competitors.
And of course, you have to put the size of the market in perspective. The whole membrane market is worth about 3 Dreamliners.
Well put.
So I think,
Well, now, is that new membrane or replacement membrane? Because there's a fair amount of membrane out there already.
No, that's annual sales.
I think the interest in China is not really so much for export back to the States is using and consuming, because they've got worse problems for water than the U.S. does. So there's really an intrinsic
Yeah, but
market wanting control.
I've noticed lately that I'm getting a lot of emails in Chinese characters. And I can only suspect that they're trying to sell me something to do with the RO business.
Well, I'm sure that they're doing a lot of that, but I think a lot of the investment, there are a lot of people in South America that are looking to get into membrane,
Right.
and parts of Eastern Europe and stuff too. That just everyone wants something that's closer to their own market.
What about large format membranes? You know, we've talked a lot about, I've talked to some of the other people about, you know, Fluid Systems' entree into that market for the Yuma project. Filmtech at one time was talking about a replacement for a DuPont bundle, which was like 11 inches or something, 10.5 inches or something like
They
that.
actually had 11 and a half, and they sold 2 small systems in the late
And
80s.
now-
And then now the
Now we're
industry is
talking about-
standardized on a 16-inch.
Yeah, except for Coke.
Well, Coke
I think they've given
is
up.
probably given up. I'm not entirely sure that's correct, but
Yeah.
I would surmise that they have. And everybody's waiting for Sarek, which is an Israeli project to
Right.
start up, the largest one in the world at the moment. And that's vertical, 16-inch
Right.
vertical, which is, has another bunch of challenges. But you may see large 16-inch plants more commonly after that one starts up successfully.
Now, we've done some studies in Florida and elsewhere, and the cost doesn't seem to be tremendously different from
I
an
think that's
8-inch.
exactly correct. It's the savings is overblown. It's really in footprint. I
Yeah,
think is where
exactly.
your savings
Exactly.
is. Yeah, that's
And
exactly
it,
right.
you know, it would seem to me that that's a marketing tool that you would use to market the large format membranes,
Well, I think they're
particularly to municipalities where, you know, often they can't buy a big piece of land anymore.
one of my involvements with Koch's interest in large elements was working with Metropolitan Water District here. And they were convinced, and that was a kind of an epiphany for me, that they're such a big water purveyor and they do it on such a big scale that they looked at the 8-inch commercial products and said, we would never even touch something like this. This
Right.
is, to them, this was a toy and immature technology. And so that they spent money, California state money, and worked with partnering with other people to really jumpstart the large diameter, and with the view that there would be some cost savings in terms of how the plant was laid out and that. But I think it was more just they didn't think that these would be robust enough until you scaled up into something that was big and all that. They just didn't see it in the type of environment of hardware and equipment that they saw in their mature water operation. So to me, that was the idea. As you go from 4-inch to 8-inch to larger, you're really showing the technology maturing to something that is really suitable for truly large-scale water projects.
Do you think that one of the drawbacks is the fact that you can no longer pick one up and load it?
Well, but think how many things in life that are, if you're
Oh, I
in
know.
a plant, I mean, that was one of the things the MWD guys were talking about. Well, the pipes coming into some of their equipment, they can drive cars down,
Right.
And so when you think about that scale, they're not going to think of it whether it's convenient to use or whether you can pick a wrench up, or not. They think about the size and scale of what it can do for them.
Well, I've done 3 different projects that involve 16-inch membranes. 2 in Dare County, North Carolina, and 1 in Collier County, Florida. Now, the Collier County people, we gave them an option. We said, you can have an 8-inch, and it's going to take up this much space in an existing building, or you can have 16-inch, it's going to take up about 2/3 of the space. And they opted for the 16-inch in an existing building, which really, it's a little bit more expensive.
I think, to me, one of the visionary people in terms of what could be done with large scale was the Bureau of Reclamation when they designed Yuma in the 70s. These guys were people that are big civil engineering type people, and they laid out their plant, even though a lot of it was 8-inch and they had the 12 3/4, they laid their plant out completely differently than
No,
conventional
it was actually
thinking.
eight
So-
and a half. The Hydronautics part was 8.5.
But, their concept there was that everything in a rack was in parallel.
Yeah.
And they arrayed their racks. They didn't try to do arraying and piping
Right.
within a rack. And so
Right.
when you start thinking, and again, this was like 30 years ago, and all the RO experts were aghast by this. But I think that's exactly the way that the large diameter things are going to come out, and I think that's a lot.
I think large plants will come out that way too.
Yeah, exactly. And
Large
so
plants.
as you get to these plants that are truly massive, then they're going to be moving, driven for those.
There's one other component we haven't mentioned in much depth is the pre-treatment and the knowledge to run one of these plants successfully. And that knowledge has gotten better and better every year. The problem with if you were running 16-inch 10, 15 years ago, you'd be in and out of the vessel changing membranes all the time. And today, you don't do that nearly as much as you used to because you've got your pre-treatment running properly.
Right.
So you can put a 16-inch in, and it will live its whole life maybe in that vessel, and then you'll take it out. So you don't have to get in and out.
That's
Like-
kind of what I
like
was
we
saying
did.
about you got to keep it clean.
Yeah.
You
Yeah,
have
exactly.
to find a way to
Yeah,
deal
but you
with
think,
things.
from the other side of the fence, I would never advise my client to invest in equipment to load and unload 16-inch elements. I would expect the membrane manufacturer or the membrane supplier or the system supplier to have
Somebody
such
should do it.
equipment
Yeah.
available.
Well, someone will have to do it and then get paid when the time comes
Sure,
to do
exactly.
it again.
Exactly.
Certainly.
But-
But then what do you do with the discards, That becomes a real problem.
Well, that's become a real, in fact, there's a conference, I think in Italy, sometime coming up, where the subject of the conference is what do you do with used membranes, RO membranes? Which was, it should take about 20 minutes. Now, somebody in Israel, I think, is actually buying them and using them as fuel.
There's people in the U.S. that are on markets to resell them to.
Yeah, right.
Other
Yeah, I mean,
people's.
if you got a 99.5% membrane and you don't need it, but 98%, you can buy an old 99.5.
Well, the rejection's only part of it. If it's
Yeah.
thoroughly fouled, then it's useless.
My last questions two, is having been involved in this industry, and some took some time off to play on sailboats and stuff like that, but would you do it again?
Sailing? Yes, of course.
And more.
Actually, the membrane industry has been very good to me over the years. I can't complain. And would you do it again? I don't think any of us consciously chose to go into the water business. Not one of us. It was one
I
of the
did.
things you fell into, and
But then I'm British.
but then it wasn't bad. So yeah, I'd do it again.
Ron?
Yeah, but very differently. Yeah, make a few
Truly.
changes.
Rick?
Yeah, I think I would because I don't know any different. I mean, it's been just like Tom. It's been a good. I've seen the world and made a living at it, but at the same time, if I had a chance to join Google
Yeah,
or
actually,
something
I remember,
like that,
I remember running into you in Raffles in Singapore one night, many years
Okay,
ago.
Well, and I saw Tom in South Africa when
Yeah.
he was down there, and we've all really had a chance to see the world in
Yeah,
a way
that's right.
kind of surprising,
That's
for
right.
the average
That's right.
engineer.
Yeah, if you'd been building lime softeners, you probably wouldn't have got much outside of the U.S.
Or Saudi or something.
Right. Terry, what about you?
Well, it was still pretty difficult when I came out of the Navy to get a job in San Diego. And I interviewed in several places, and this was probably the easiest one I could get. And it's never paid all that much over the years. It's gotten better more recently. But my son had an interesting perspective. He was at Santa Barbara at the time, and I said, well, I know Ashwin Desai at Membrane Systems, and you want a summer job, I'll see if I can get you one. So he went over there and interviewed, and they offered him, slightly above minimum wage, and he says, well, Dad, why would I want to work for $7.50 an hour when I can valet park cars and really exotic stuff that I can drive real fast in 50 feet, and I'm averaging about $12 an hour? And I said, Why indeed? But he graduated as a mechanical engineer, but he's in plastics. You remember from the
Yeah.
the name of that show, where you know which one I mean, where that kid was told to get into plastics.
Oh, yeah.
But
Yeah.
Graduate.
The graduate.
That's right.
you know, I agree with Ron. I do things differently. I remember sitting there with Dick Sudak and Seymour Kremen and Iz Nussbaum, and they were looking at Dean Spat's first prospectus to go public. And Seymour was going, this is junk. It's never going to work. You know, he's going to go broke. And that was consensus. He was going to go broke. I still remember that.
Yeah, that's right. That's right. During your careers, is there one person that you feel had a significant influence on the direction you took? I mean, you were in R&D and you moved it more into the production side. Is that because of
I think it was
a
just
mentor,
more-
or just because it's something you wanted to do?
It was more in line with my interests and whatever. So,
Yeah.
and I guess from that standpoint, I've got to give Dick Sudak the credit because he took a chance with me. I was just 1 year experience from the R&D lab and let me work on some of the big hardware things, and it was very stimulating and interesting to me. So it helped me going down the direction I did. So was Dick here in part of the interviews, or
We interviewed Dick. He was
Yeah,
one of the
okay, so
first group.
people had
Oh, it
a
was.
Yeah,
yeah. Okay,
Yeah.
well, so thanks, Dick.
yeah.
So he came down, did he?
He was no. We interviewed him 2 years ago in San Diego.
Oh, wow.
Okay.
With Bob Riley and Randy Truby. That was the first one. Tom, did you?
Well, obviously I worked for Iz Nussbaum, kind of one of the legends of the business. And he was very good to me over all the years, and we stayed in contact all the time. And so he was always encouraging to whatever. So, I mean, he would be the guy. And when he died, his daughter called me up and said, hey, all the books and papers are yours. They've been left to you. If you want them, you can. If not, I'll donate them. And so I told her to donate them, but that was, I thought it was pretty good. He was a good, interesting guy.
I didn't know him very well, but my first encounter with Izzy was at one of our conferences in Key Largo, strangely enough. And I was, this had to be in like 73 or 74. I was a little wet behind the ears still. And I had been charged by Nuissia with being the nominations chairman. So everybody that was on the board of directors at the time decided that they wanted to continue on the board of directors. So we ran a slate with nobody but the people already there. So we got a challenge from the floor led by Izzy Nussbaum, Leon
No doubt.
Bach, and Herb Sliger.
Oh, okay.
And my life has never been the same since. Terry, what about you?
I think in the early years when I changed companies, Jerry Foreman, Jack Luce, and Dave Furukawa were instrumental. And I think in everyone's career you come to a milestone and you go left or right. And I think I can look back and say I was only out of work for 5 days during any period during my working career outside of the Navy. And I may have made the right decision. But those three people influenced my decisions early on.
Ron, you obviously weren't influenced by Bob Riley because you got him the job.
No, he's a good guy, though. But I was influenced, by a variety of people. Initially by Ulrich Merton. It wasn't so much to go into that field, but his tremendous intellect and trailblazing mathematics and so forth that went into the definition of membrane technology. And I thought, well, he's interested in this. I'm going to watch it carefully. And but I tell you what, that from a practical point of view, I got along with Seymour Kremen just wonderfully. And I give him the credit. He was a guy who had extraordinary background in a lot of things. And I'm sort of a person of many parts of the world, and he knew something about all of that. There's nothing like traveling with Seymour. He would give you a complete history of every single thing about everything that went on 300 years ago in this area. And Very interesting, and plus he was tough, firm, and fair in all those things, and I sort of survived all that. But in any case, I also give credit to my career changes to Dick Sudak. I had a great respect for him and his humanity and engineering capabilities, and I just wanted to work with him. I thought we would do great things together, and we did. He quit, and he left me running that company for the period of time that I had it. And I will also say that I had a lot of respect for Jim Bartlett, who ran Hydronautics in those days, and I still do. He runs, he doesn't run it anymore, but he's up there owning Tricep and working with Bardex and whatnot right next door. So I go up there once in a while and on a consulting basis, and I always find him interesting and thinking of more things than other people think of. In a meeting, he will dig to the bottom of the questions of everybody's knowledge about whatever they think they're talking about, and he'll root that bottom part out and then find out what's left is we need more. Mm-hmm. So, and I thought, well, he's quite a human being and yet very smart person intellectually and from a business point of view.
I enjoyed working for him.
I'll bet you did, yeah.
I really did.
Yeah.
In fact, I think that's when I first met you, when he sent
I
me
think
down
so.
to visit with you and Dick.
And he thought that it would be a good thing for you and me to go out to dinner.
That's right.
And he was right.
That's
He was
right.
again.
There you go.
Can I interject one name that
Yes.
I suddenly thought of as almost a secondary thought, but Al Riedinger, I mean, apparently he's passed on, so I know he's not part of these interviews and stuff, but I think all of us were, when we were young, we used to kind of tease him a little bit because he was a kind of a curmudgeon-y guy and everything. But looking back in my life, I realized that I learned a lot from that guy.
Yeah,
He's a smart guy, yeah.
Yes.
He was a chemical engineer, I think, from Caltech or whatever, and he was really the first person, the first on the spot with the spiral element, this kind of configuration, and did a lot of the original pioneering work on how to model this thing. And now people have improved. Tom has become an expert on it and all, but when you really think back, here was a guy on day one. And he's just a name that doesn't get mentioned too much.
Right.
So, and here I'm mentioning it as a second thought.
There were several people have said that. as
Okay,
well.
good. Well, I'm
Several
glad
people
that
have,
he
yeah.
did get remembered.
I would add that in my own background, I found that Don Bray was a remarkable guy, brilliant chemical engineer and mathematician and predictor of the future. And he was always sort of right. It may not have happened this year, but give him 3 years and it will come out that way. And
I've not been that way about osmotics, but anyway.
but he took them for a bundle, and so
That's with Dean at the helm. That's no small achievement.
yeah, well, that's right, and he was, in spite of his stockholders, he was generous to his staff upon the sale. The way he could do that is he just went and bought stock back from the stockholders and said, "You aren't going to tell me what to do," and then he went ahead and did it. And I had a lot of respect for him. So he was instrumental in me making a job change at one time, key reason, so I give him some credit.
Good. Well, thank you very much, and hope to see you this evening.